Support for Digging Deeper comes from the Penn State Alumni Association, connecting alumni to the university and to each other. The Alumni Association is powered by pride. Learn more at alumni.psu.edu. And from viewers like you, thank you.
There are currently 7.5 billion people on the planet. According to the United Nations, that number will grow by roughly 83 million each year, reaching 9.8 billion people and counting by 2050. To feed that many people, the UN estimates food production will need to increase by 50%. In this edition of Digging Deeper, Penn State President Eric Barron will discuss the efforts to increase food security on a planet where 815 million people are already hungry. Joining him are Penn State professors Jonathan Lynch and Kathleen Brown. I'll be back later in the show with a one-on-one conversation with Dr. Barron.
Maybe, Jonathan, we'd start by just an idea of what exactly is a roots lab and why is that so important?
Well, our lab focuses on figuring out how we can get better root systems for crop plants. And that's important because in the poor countries, yields are low, which is a major problem for food security and economic development. Yields are low because of lack of water and nutrients. So better root systems is going to directly address that problem. Meanwhile, in the rich countries like America, we're intensely fertilizing. That causes huge environmental problems. Mm-hmm. And drought continues to be a problem for rain-fed agriculture. So here also, better root systems would be more helpful. So our goal is to understand how we can guide people to breed crops with better root systems that are more tolerant of drought and less requiring a fertilizer.
So, Kathleen, it seems to me that I would have, thought that people would talk about, okay, maybe there should be more fiber or more protein or more fruits or bigger and fleshier fruits, and a focus on roots. Just how essential is that in terms of focusing on food supply? Can I have none of the above without good roots? Is that the idea?
All of the above require roots, right? Roots
Yep.
are doing the job for every kind of plant, so that we work mostly on grains, legumes and grains, but that are important for fruits and vegetables and every other crop too. And the part we eat is usually part of the shoot, except for potatoes and a few root crops, but all of those depend on nutrients and water that are coming from the roots.
So, water and fertilizer. Water is, of course, incredibly important, and drought is an issue, but it's also significant for runoff and taking good care of streams and waterways. Fertilizer fits in right within that topic. So how does the water fertilizer issue match up to what you're trying to do with roots?
It fits in very closely. As I was saying, well, in poor countries, once again, fertility is low, and so they don't have these environmental problems. They don't use fertilizers in general. But here in America, we intensely use nitrogen and phosphorus fertilizers. Those run off fields into waterways, cause algal blooms, tremendous problems. In fact, right now there's a big algal problem in Lake Erie. Mm-hmm. Furthermore, nitrogen can leach into groundwater, contaminating wells. Nitrogen can go off into the atmosphere, causing greenhouse gas. So actually, nitrogen is the biggest nitrogen fertilizer is the biggest cost of growing crops in the U.S. and the biggest environmental impact of growing crops in the U.S. So if we could reduce the nitrogen requirement by having plants with better root systems. Now, over half of the nitrogen fertilizer we apply to crops is never captured by the plant. It goes right off into the environment.
Escapes.
It escapes.
Yeah.
So if we had a tighter system, better roots that would catch that, save growers money, save the environment, and have a more sustainable ecosystem.
So how about comparing and contrasting? The Roots Lab is doing this for a developing country, and at the same time, here's an aid for the United States. How does that, it sounds like it works for both.
It does work for both. So for just to give an example, after many years of effort, just this year, our team, in collaboration with partners in Mozambique, have released new bean varieties, and bean is a staple food for these people in Africa, that can yield twice as much as the best varieties we had before in those stressful soils of Mozambique. And that was a result of figuring out what is a good bean root system, how do we select for that, and then breed for that. So that's a direct impact for Africa.
So this is poor nutrient, not enough water,
Yep,
and you're selecting, in a sense, a root system
that's right.
that is designed for that environment.
That's right. We can double or triple yields without fertilizer, without irrigation, just by having a better root system. And I think this is something everybody knows. Roots are important for, capturing water and nutrients.
Yeah.
But breeders need to know, well, specifically, what exactly should we select for? How do we select for that? And what's the genetic control of that? How does it work in those environments? And so that's our work. So we can hand that to a breeder. We work with breeders. So it's like, if you select for this, this will have a benefit in your environment. So that's a direct impact we've had in Mozambique and other African countries. Meanwhile, here in America, we just started a large project from the Department of Energy geared towards developing corn with deeper root systems, which is going to help American farmers with drought tolerance. It's going to help them catch nitrogen as it leaches through the soil. Deeper roots will catch it. And also, according to their analysis, it'll capture a significant amount of carbon dioxide from the air. So reducing these carbon emissions and put it in the ground where it does good as soil organic matter.
So you're capturing the CO2 and the carbon is then deposited in the soil.
And the deeper you put it, the longer it stays there.
Stays there.
So deeper roots, they estimate that deeper rooted corn alone, which is the biggest crop in the U.S., could capture a significant amount of the total U.S. carbon emissions.
So Kathleen, what precisely do you do in this project of trying to tune the roots to fit an environment?
Well, we do a series of things. One of them is to try to identify which root traits are important in which environments. So the idea of a crop root idiotype, which means an ideal phenotype in which you have shallow roots will help the root system capture phosphorus, deep roots will help the root system capture water and nitrogen. What if you have both or all three stresses? How do you combine them? We have different concepts of root efficiency and thinking about what characteristics of the roots will make them more efficient. They can't just be bigger, because if they take resources from the shoot, and the roots are not photosynthetic, so they depend on the shoot for their carbon, that takes away from yield if you make the root system too big. So we have to think about making the root system efficient at capturing the resources that the plant needs without taking away from yield. So we think about what are the traits, how can the root system be more efficient, where is the best place to put roots in different environments. And then from there, we have to come up with ways for breeders to use them, because we dig up roots with a shovel and they don't want to do that. For thousands of plants, it's too much work. So instead, we come up with either molecular markers or simple phenotypic screens where you can look at it with your eyes or with a magnifying glass and say, oh, I see the thing I'm looking for, select this one and not that one.
So literally, you could promote the development of a plant with a giant root and a little teeny plant?
Well, plants will do that. When they're under severe stress, they'll start to put more resources into the roots at the expense of the shoot, and that will reduce the yield, assuming that the yield is in the shoot, which it usually is. So
can you design a root for resiliency, for a climate that's highly variable? Because it seems to me that in a lot of cases, you sit there and you talk about a drought in Mozambique, but you could have a drought in Florida or a drought somewhere else, and most of the rest of the time, you'd have a very wet environment. So can you design a root for resiliency?
You can, and this is, as Kathy was saying, an idiotype is like an ideal goal for a breeder. We could tailor that to particular soils, regions, and so on. But Eric, we work on 5 continents, and so far we found that the same kind of root characteristics work in many different soils. So I'm not sure that we have to fine-tune it too much, which is good for breeding, because if the breeders have to think about just Pennsylvania and it's not going to work in New York, they're probably not going to do that.
Yeah.
But so these are things that seem to work across a large range of environments.
And when you say you work with a breeder, that's someone that a farmer would buy seed from or buy a plant from. You're not an individual farmer.
That's correct. So American farmers will buy seed from a seed company. Somebody either in that company or maybe a Penn State breeder or somebody who's licensed to that company has developed, after worked many years to develop this cultivar, this line, which particular characteristics. And so there's a lot of breeders around the world. Now in Africa, we work with public sector breeders who work for the government. But in working with corn in America, now we're working with big seed companies. But so the users of our information, in addition to other scientists, to have impact, breeders have to say, oh, that's a good tool, that's a good trait. Let's put that in our breeding program and develop a better plant.
So can you say how exactly it is that you put the trait into a plant? Is this crossbreeding? Is this genetic engineering? Is it?
It's just conventional breeding for the most part. For example, we have a project that's funded by the U.S. Agency for International Development on beans for tolerance to drought and heat stress. And there are 11 institutions on the project, and most of the people at the other institutions are plant breeders. And they run field trials, and they make selections, and they make crosses, and people like us will help identify what are the parents that you could use to get a particular trait, but they'll start making crosses and incorporate it into their lines with other characteristics that they know that their growers are going to be interested in. So those are all public sector breeders in the United States, Central America, Africa. There's a lot of people on that project that breed for different areas.
So one of the interesting things, excuse me, Eric, one of the interesting things I was going to say about this is that plants have been adapting to living in soil for 450 million years. And during that entire time, they've had to deal with variable moisture,
drought,
poor nutrients. So one of the kind of interesting elements of this challenge is we're trying to make a plant do something better that has already been working on for a very, very long time. So the easy wins, the low-hanging fruit, nature through evolutionary selection.
It's already managed that.
That's right. So we're trying to say, well, can we do this even better? And that's what kind of makes it more challenging.
What drives you to pick a particular crop? Are you basically looking at it from the viewpoint of this is a food crop, this is a fiber crop, and therefore we really need to be driven to improve that crop? Or do you look at it from a viewpoint and say, well, you know, corn is a good one to breed and it's a valuable crop, and so let's do these experiments with corn? Or do you have like dozens and dozens of different types of plants you work with?
Our main focus has been common bean, because that is the most important food legume on earth. And that is very important in Africa and Latin America. So we started that work because of its importance, not because it was easy to work with. And then we picked up corn. Once again, the most important crop on earth, most important crop in America, very important for food security. So it turns out corn is actually a good system to work with in terms of its genetics and so on. But our main goal was to have an impact and not what's the easiest system. Now, having worked with corn and bean, it turns out that most of our food crops are either legumes or cereals. So a lot of our work, our methods, our ideas are being picked up by people in other crops. In fact, we have projects on rice and cowpea and wheat and so on. So I think those, it turns out in retrospect, corn and beans was a good focus. But we went into it thinking, how can we make a difference for food security?
And how do you connect with a breeder? So you've picked those crops, and obviously it sounds like other people are interested in expanding the scope of plants depending on what they're growing in a particular country. But how does say a public sector breeder in Africa find you, or a large seed company in the U.S. find you? This is highly visible to them because of the USDA support, or how does that work exactly?
Well, yeah, that's an important link, and you know, I have worked with crop breeders my entire career. My first position was in the International Center for Tropical Agriculture in Colombia, South America, where we directly interacted with African breeders and Latin American breeders. And so it's the networks of people you know, and then as Kathy said, we have particular projects like this project from USAID, which is geared towards that sort of impact. So there are those folks out there. If you work if you travel in those circles and have those networks, you can work with those people. Now, in terms of the seed companies, they're constantly looking for opportunities. So they come to scientific meetings and hear talks. They come to Penn State, and so they know what we're doing. And they'll say, we'd like to work with you because you're doing something important for us.
So I said USDA, U.S. Department of Agriculture. You said USAID. A difference between supporting in the U.S. and supporting in countries around the world.
We've had significant support from USDA also.
You have, okay. So So one other, perhaps you could tell us some what you would call real success stories. Are there examples where, wow, this really worked well, and we're now really impacting the?
Well, I think, to my mind, I mean, the most concrete, tangible success is new, better seeds with better root systems that are producing more food for people. And I gave you the example of the work in Mozambique. And those lines, those seeds are going to be used throughout southern and eastern Africa. So that's a very significant, because people there depend on beans as a source of income.
So this is just now spreading multiple countries, and then you know it really worked.
That's right. So we're getting double and triple the yields we had before, and the governments are sharing those seeds, sharing that information. So that'll get out to the growers, to the farmers, which is going to have a significant impact. The impact we're having with corn in the U.S. is, we know that our discoveries are being used by the seed companies, but they're private companies that keep secrets.
So you don't know
So
exactly.
they won't tell us, we use this for this line, that's all a secret. But we know from the questions they ask and the interactions we have, they're interested in what we're doing, and they're following that. So we think we're having...
So that's a good sign, but you'd think if you had stronger feedback, it might set you off in different directions.
Well, I think we're ahead of the companies. We know what we're doing better than they do, so I don't think we'd follow their lead. But I was going to say, another very important impact in this area is training young people. There's a large need for young people, young scientists to do this kind of work, who have this kind of knowledge. And we're talking about the interface of plant biology, soil science, and so on. As very few people have that
crossover
expertise. And so just by training young people, that's, I think, where our real impact. And we have graduates from our group who are now in international centers and universities throughout the world and research centers, and here in America. And so I think that's, as a professor, I think the impact is training the next generation, which is really going to have to take this work forward.
Do you have areas where you just struggle? This is a plant that, defies our process, or...
The traits are extremely complex, and we do struggle. We struggle constantly with how do these traits interact, and what is the plant doing, and under what circumstances is it doing this versus doing that, and how can we take into account all these interactions when we try to study the impact of particular traits on the performance of the plant. So it's difficult, and then as a scientist, of course, you always have to learn new fields. We have to be able to talk to the geneticists and breeders, and those fields move fast. We have to understand what they're saying when they talk to us. So we have to develop those skills in our students and keep them up to date with new technologies and being able to interact with the kinds of people they need to interact with to have the impact we hope to have.
We've had to develop tools to do this work that nobody had developed before. In silico tools and conceptual tools, but that's where you need to be, I think, as a scientist. If you're not struggling, then perhaps you're not pushing yourself hard
Right,
enough.
yeah. What type of measures do you have that you know you've made it? So we had a drought, and my field is still safe, and the other fields around it are not. Is that the basics, or is this measuring the amount of bean production that comes out of? What kind of metrics do you know where, okay, this really is a success story here?
Well, I'm always very happy when we're testing some new trait that people haven't thought of before as useful, some new root trait. And we'll create genetic contrasts where the plants are very similar genetically, except for this trait. So we'll have long root hairs versus short root hairs or something like that. And we'll put those out in the field under stress, under drought stress, phosphorus stress, nitrogen stress. And we see that having that trait makes this plant yield significantly more.
So this really is a yield discussion.
Yes, it's like, if you can yield more with that trait, okay, now we're on to something. Let's figure that out, and breeders can use that.
Yeah.
So that's what's exciting to me. There's also the excitement of, as you say, working with young people who have their own ideas. So that's.
And do you ever go, okay, that has a much bigger yield of beans, but they don't taste the same?
The breeders have to take a lot of those extra things into account. So we focus on the root traits that will help with the performance of the plant and getting the resources the plants need. But that is not the only thing they take into account. That's why we need to develop easier screens for them, because they have to think about disease resistance and grain quality and cooking quality and appearance even. Like with the common beans, people in different countries have different preferences. And if they prefer small black beans, they don't want big red beans. They want the type that's part of their food culture, and the same thing goes for rice. People have preferences with rice. of grain quality and taste and so forth, and they're important to the culture, and you can't ignore that.
Yeah. So it really is incredibly complex, not just from the plant side of things, but also
Right.
people's expectations. So to add to the complexity, we've got a topic like climate change, for which there's a tremendous amount of debate. How does all of this play into the climate change debate?
Well, I think very significantly, because with climate change, what we're seeing and what we expect to see is changing precipitation patterns, which means you could have more incidents of drought, intense storms, which cause runoff, more environmental pollution, more leaching of nitrogen. The production of nitrogen fertilizer is a driver of climate change. It takes a large amount of energy, and then nitrous oxides from fertilization are a greenhouse gas. Furthermore, the idea that roots are taking carbon out of the air and putting it down in the soil, that's a way to kind of mitigate some of these pollutants that we're putting into the atmosphere. So climate change is actually a very significant factor in pushing this research, because as bad as things are today, with the growing population and a changing climate, we're expecting them to become more challenging in the future. So I consider this issue, not just roots per se, but developing crops and cropping systems for the year 2050 or the year 2100 as a huge civilizational challenge, a challenge to our species. How are we going to support so many people in a changing climate?
Yeah, yeah. It's a fascinating topic, and I see really clearly just how important those root systems are. But here in just our last minute, what else would you add? Roots, but if we're going to provide the food supply for the world, what else do we need to focus on?
Well, I think the important thing to remember is we can solve this problem. It's a massive, challenging, complex problem, but these are things we can solve from many different directions. So a lot of people can contribute to solutions to this problem: energy efficiency, or better agricultural systems, or training the next generation of scientists. The main thing I would say is we have to take this seriously, look forward into the future, and say we have to start developing the knowledge now to develop the solutions for 2050. It takes 20 years to breed a plant. So unless we're training those people now who are going to develop those technologies,
we're not going to
make it. We're
Yeah.
going to be behind. So I think we can do this, but we have to take this very seriously.
Significant role for Penn State. Thank you both so much for joining me today. Fascinating topic.
Thank you very much, Eric.
Dr. Barron, thank you so much for joining me today.
Happy to be here.
All right. Well, Penn State's Counseling and Psychological Services, otherwise known as CAPS, is now offering free drop-in chat sessions in each of the 5 commons areas at Penn State. Why is it important for students to have this kind of access to counseling services?
So I think there's lots of factors here. One factor is we know the demand is increasing, and we want to make sure that we match what we provide to the growing demand for psychological services. And second, sometimes getting an appointment in 2 weeks is not the most efficient way if somebody's under stress. So having the opportunities for students to drop in and make it easier for them to do it and helps relieve that stress and provides an opportunity that we might not be able to do otherwise. There's a really good story in the midst of all this issue of growing demand, and that is the students voted on the fee board to increase the fee to provide increased psychological services. And Penn State, along with all the other Big Ten schools, have a new media contract with an increased payout to the university. And athletics and myself, we decided we were going to take part of that and match the student fee. So we have truly a substantial increase in our capability to deliver CAPS services to our students.
And you mentioned stress. It is definitely big for students here at
Yes,
the university
it is.
because midterms, and they're working very hard. We all are. And in October, Dr. Joe Biden, the former Second Lady of the United States, came to visit Penn State, and she spoke about the many challenges in her life, being a mother, an educator, and of course the Second Lady of the U.S. And Dr. Barron, you're a busy man yourself. What advice do you have for students who are also challenging with a balance of work and life and school and just everything going on in their world?
So I should have gone and listened to her because I'm terrible at it. But I really do think that if you get to that point, you know, and some people tell you there's even a sweet spot where you can sense that if you're working too many hours, if you have too big a course load, it actually degrades your ability to perform. And if you do too little, then perhaps you have too much time on your hand, and it assists you in a little bit of procrastination. So there is a sweet spot for how it is that you function in a university environment. Now, my problem is that I haven't been very good at it, but I know that it's there, and I strive to find it. But really, I think that sense of not to be overwhelmed, and but also to be engaged, so you really feel like you're operating at your peak, becomes important.
What is one of the things that you think maybe has helped you over the course of trying to balance a busy workload?
Well, to tell you the truth, my wife has helped a lot because she basically looks at me and goes, "Okay, come on, Eric, give it up a little bit here. You're just not going to be effective if you keep up at that pace." But I think we all need our self-monitors as well as having somebody else help us.
Thank you so much, Dr. Barron. Appreciate it.
Thank you.
Support for Digging Deeper comes from the Penn State Alumni Association, connecting alumni to the university and to each other. The Alumni Association is powered by pride. Learn more at alumni.psu.edu. And from viewers like you, thank you.